Hello everyone, today I'm going to talk about tip-jet helicopters, or the most Kerbal-like helicopters to ever actually fly and carry real humans. And the basic concept as such is actually somewhat self-explanatory. A tip-jet helicopter uses some sort of propulsion method that is attached to the tip of the rotor blades to spin the rotor instead of using a torque-producing engine and then transmitting torque through the drive shaft and into the rotor. Now these propulsion methods can vary, and most tip-jet helicopters actually have engines within the fuselage that create pressurized air and then pump this compressed air through a hollow shaft and through hollow rotor blades into the rotor blade tips, where it exits through jets or nozzles that are directed so that the rotor starts spinning and produces lift. A tip jet where there is no complex mechanism, no fuel combustion within the rotor blade or tip, is called a cold tip jet, although the air can actually be pretty hot from the compressor, especially if it's a turbojet type compressor. And these make up most actual operational tip jet helicopters ever built. But then when they're named cold tip jet helicopters, there are of course also hot tip jet helicopters. Those are ones that do burn fuel in the rotor blades, but usually that's only an afterburner or some other addition to the airstream which is already provided by an engine within the fuselage. These also make up quite a few operational helicopters. And then there are some exotic designs with actual complete propulsion systems on the rotor blade tips, be it propeller engines or jet engines or even rockets. Of course, one advantage such a tip jet helicopter has over a more conventional helicopter is that there's no real torque being transmitted from the fuselage to the rotor, and so you don't really need an anti-torque system. So you don't need a tail rotor or something similar, or coaxial rotors, to counteract that torque. You can simply use a rudder like in any airplane to steer your helicopter while flying forwards. However, there is a bit of a problem because you do still need some amount of yaw control while hovering still. And of course, the helicopter rotor still has some amount of friction in its bearings, so even if that is small, it will slowly start spinning the helicopter up. So you do need some amount of yaw control even when hovering still, which a rudder can usually not provide. So usually these designs either divert some small amount of air to push it over the rudder so that this rudder has an airflow even when the helicopter is standing still, or they just use the exhaust of a motor that powers a compressor to create some rather small amount of airflow over the rudder so that you have some control even when the helicopter is standing still. Although there are of course some exceptions where either aerodynamics using the downwash from the rotor are used to spin the fuselage opposite to the rotor, and then you could have something like a brake to control the friction between the rotor and the helicopter. There are some alternative designs for this yaw control, but usually it's a rudder and you just lead some exhaust over that rudder. But even with that, generally these designs do have a bit of an issue with yaw controllability and torque control. Generally, while these do offer some minor advantages, the tip jet helicopter isn't really an optimal helicopter design, and it was mostly used in the 40s and 50s when helicopters were generally still a rather young idea as such. In this time, a lot of experimentation was done with weird or unconventional helicopter designs, And the tip jets do have an advantage for that time. For their time, they were relatively simple to build, even though they had their own difficulties. They did function without some of the more challenging engineering challenges that you have to face for a more conventional helicopter. So it makes sense that you see them in early helicopter times. And also compared to the other possibilities you had at the time, they had quite a good lifting capacity. The strictly motor or torque turbine driven helicopters of the time had very little lift compared to today, and for their time, tip jet helicopters had quite a good lifting capacity. They could lift a lot of weight, but they couldn't fly fast, they couldn't fly efficiently, they couldn't maneuver very well, and they did have some safety issues because, for one, they did have very little yaw control when flying very slowly, and then they had a bunch of safety issues related to the reliability of the rotor drive. Although these safety issues, they would have been quite an issue by today's standards, but back in the time, all helicopters were relatively unsafe compared to today, so that wasn't really an issue against that design. Later on, the tipjet principle still showed up in some ultralight helicopters and some experimental vehicles, but generally it's mostly phased out nowadays for standard helicopters, except for historical purposes. Although tipjet similar designs showed up early on in early VTOL airplanes or VTOL fighters, which would have 3 wings or 4 wings that could be tilted to be used as rotor blades or wings, and the tip jets would then tilt along with them and be used as propulsion engines for the airplane mode or as tip jet engines for the helicopter mode. More recently, there are some unmanned designs using similar technologies, and of course the rotary rocket concept, which was a concept for a while where the idea was to have a rocket that would fold out rotor blades and then basically convert into a tip jet driven helicopter and land vertically as a helicopter. Aside from that, tip jet helicopters today are mostly old aircraft being flown for historical or research purposes, and there isn't really any special purpose where they could outcompete more conventional helicopter designs anymore. So I hope you found this little video about tipjet helicopters interesting, and as always, thanks for watching.